Hello, welcome to Train Signal. This is Introduction to the vnx series. So before we get started, we've gone over a little bit of what's common in most storage environments. So I hope that's given you kind of a baseline of where this course is heading. But that was purely a baseline. So now we're getting into the vnx itself, which is the essence, the root of where this course is going. But I wanted to give, like anything in life, when you know your history, you know where things come from, you can kind of maybe understand where they're heading. The vnx itself is really the fifth generation of mid-range arrays from EMC. Now, I put a note in there, the FC series, which encompassed the 4500 and the 4700, were released between 1999 and 2001 in this timeline. Now, in 1999, EMC purchased the Clarion line from Data General. They were based out of Apex, North Carolina, and they acquired that technology from them. Between 99 and 2001, they came out with the FC 4500 and the 4700. Now, the 4700 in general was, I don't know about the 45, but the 4700 was a huge purple array. It was hideous, absolutely hideous. But it's where I cut my teeth, and that's how long I've been working with these arrays themselves. It was back in that right around the 2000 range that I started working with the 4700. Now, soon after that, about a year, they came out with the CX 200, 400, and 600. And this was really their branding, EMC's branding of the Clarion technology itself as they saw it. What changes occurred when Data General owned it, when the FC series came out, and when the 200, 400, and 600 came out? I can't answer that. I'm not sure all the different features and modifications that were made once EMC got their hands on it. But that was the first, really the first introduction to market of the Clarion line as we know it. And that was over, from 2001 all the way up to 2011. That encompassed the Clarion line itself. So when most people know what a Clarion array is. It was really up until the vnx, which was in 2011, where the name changed. As far as I'm concerned, the same underlying technology. A lot of the bus structures, it went from fiber channel to SAS. There was a lot of other key things that changed with the line, but it was still a clear delineation between the file side, what we call data movers. Dart was in the previous NS line, and the block side. So right around 2003, and you'll notice the time difference here. You'll notice this across the board. So a couple years between 99 and 2001, a couple years between 2001 and 2003, 2 or 3 years between the rest of these entries here. That's about the release cycle for EMC's mid-range array. 2003, CX300, 500, and 700 introduced. And then the AX was introduced. It was kind of a low entry point into this space. This would be, essentially the predecessor to the vnxe. Then in 2006, you had the CX3 line, so the 10, 20, 40, and 80. And then 2008 was the CX4, 120, 240, 480, and 960. I always loved this line. I always loved the CX4 simply because it made my life easier actually knowing what the max discounts were in the array itself. CX4, 120, 120 disks max for that array itself. Every other line, every other model of Clarion vnx, not so distinguishable within the name itself. Miss that. If you're listening, EMC, I missed that. As history progressed, features were added. Now, the great thing about EMC, and they do a great job with acquisitions. And the reason they do is because they take risks, and they foresee where things are going. I don't know. I'm not sure if they have a crystal ball or something where they can actually see the future, but they know what's going to be hot. And they're so big, I guess, nowadays where they can just kind of they can almost dictate what the future is going to be because they are so large. But over time, each generation, from the CX all the way up to the vnx itself, features were added that were just not mainstream at the time. These are things like fiber channel and ASCII connectivity in the same array. It just wasn't common at the time. SATA disks, certainly not common at the time. And now, within the vnx, you can now make, SAS, since it is a SAS backend bus now. You're mixing SAS, you're mixing nearline SAS, you're mixing flash drives. You have all these mixing of different drive types. That just was not common when this first hit the market. Varying levels of RAID technology. That was not common either. Typically it had one, maybe two, in early on in mid-range arrays, RAID levels. Maybe it had RAID 1 and RAID 5. Now it's progressed, it's grown even more. I mean, the VNX itself has RAID 0, has RAID 1, 3, 5, 6, 1 plus 0. I mean, it's got a whole gamut of different RAID technologies that you're able to utilize depending on your use case. I mean, it's very important you know what type of I/O is going to be written to this, or the I/O footprint, I guess is a better way to put that, is going to be written to the disk that you're allocating. That's important for you to know so you can determine what type of RAID technology best fits that I/O profile. Active passive head design, that was just not common at the time. And what active passive head design, if I could summarize in kind of a couple sentences what it actually means, is that if you have a LUN, you have a logical unit, that raw LUN you're allocating to your host so that host can write some data to it. Okay. With an active passive head design, that LUN is either owned by one storage processor or the other. We talked a little bit about SPs. So the LUN itself is actually owned by one head or the other, one SP or the other. And data therefore is, the I/O path is therefore active between one head or the other at one given time. Now, if you were to lose a head, that LUN would fail over to the surviving head. But I/O is only traversing one head at a time. That's active passive head design. Okay. Now ALUA, asymmetric logical unit access, puts this a little twist on this active passive head design, and you'll actually see EMC say the VNX itself is an active array. It's an asymmetric active array. It's not a symmetric active array like the symmetrics or the VMAX. But it's hard for me to really make sense of this because Lua does change the game a little bit, but to me it's still an active passive head design. Ownership is still to one head or the other. Also, pluggable I/O architecture. In some of the later models, this gives you the ability to buy what you need as far as I/O modules. So your fiber channel modules, your iSCSI modules, buy what you need day one. If you need to expand later, you add in a hot pluggable module. Simple as that. You grow into the array. You're buying things over time as you need that technology and capability. And then flash drive support. Huge. Flash drives in general are just becoming a huge beneficial technology to the industry, and it's really changing things dramatically. EMC was one of the first, if not the first, to introduce flash in their mid-range array. Now in 2011, the year of the VNX, this is when the CX5, quote unquote, the CX5 came out. This is the VNX. They introduced the VNX 5100, 5300, 55, 57, and 7500. So they introduced essentially 5 new arrays to market. Now the biggest changes and kind of some things that I put here in these couple bullet points was a SAS backend bus. So you're moving from a 4 gig fiber channel backend bus with the CX4, might have been 8, it's 4 or 8, and you're moving that to a 6 gig SAS bus. Now with the SAS bus, it's really 4 channels is how they explain it. It's how EMC explains it. It's 4 channels, so 4 times 6, it's really 24 gigabit of highway to move around, between the storage processors themselves and the back-end DAEs. So it's all utilizing the SAS back-end bus. Extremely more expandable and scalable than the original fiber channel bus, which was using basically an arbitrated loop type technology for back-end communications. In the CX5, the 3.5 and the 2.5 disk form factors now can exist in the same array. So why would you want to go with a smaller disk form factor? Well, now I can cram more disks into the array. So my DAEs traditionally, my disk array enclosures traditionally only held 15 disks. Now they've added these 2 and 2.5 inch disk form factor DAEs, and now I can put up to 25 in a single DAE, and even in some cases I could put up to 60 in a DAE. So it's really expandable, really scalable from the fact that now you have these smaller disks and now you have more capacity that you can throw into the VNX themselves. Also speeds and feeds, more cache, more front end ports, faster processors. You'll see on some of the forthcoming slides how that breaks down between the different models. And another major selling point is the software suites that were introduced. So these are consumable or very consumable ways to buy software on the vnx itself. So instead of going down a laundry list of all the different features and technologies available on the vnx itself, they're now grouped together based on application protection, or based on remote replication, or based on local replication. They're all put into these suites, and then even on top of the suites, you can do what's these two packs. So you can do a total efficiency pack or a total protection pack. So it really made consuming software extremely easy in comparison to times past. And we'll go over what's in those suites and what's in the protection packs and efficiency packs. Now the first model that was introduced is the 5100. Now this is the block only array. So there you have no capability to do NFS or CIFS from a data mover perspective, or from a backend file perspective. Now the max number of disks that this array can support is 75 disks. Now it's really, the minimum is 4, so every array needs 4. First 4 disks is where the OS and a number of other features and capabilities exist, but it's really the OS for the array itself. That lives on the first 4 drives. Your front-end cache, which is where basically all data hits first, is your front-end cache, and then it's de-staged to disk at some point once cache fills up or things are rotated in and out of cache. That's 8 gig. You have 8 gig available to each storage processor, and it's mirrored. It's mirrored between the SPs. The number of ports you have, I actually went back here. I had done these slides originally, and I had included just the base ports, and I figured that would be extremely confusing to everyone. So I went ahead and included the max fiber channel only ports that are available on each array, and how many buses you can do per array itself. I think those are 2 key factors that are really helpful when you're buying or designing these arrays themselves. Now there's, when you have fiber channel over Ethernet, when you have iSCSI that you're doing from the SPs themselves, things like that, you have different varying levels and options that you can do for the I/O modules themselves. I didn't include everything. I just did fiber channel, and I did the number of buses that you can do. So you'll see here on the 5100 itself, it's 8 front-end fiber channel ports. This is for host connectivity, front-end connectivity. So you're introducing these front-end ports so that your hosts can attach to, so they can access back-end disk. And then on the back end, between the communication path or the bus between your storage processors and your DAEs, where your disks live, there's 2. You can do 2 back-end buses. Okay, like as I mentioned before, this has no file level capability, so it is fiber channel only. You also notice that I did not put iSCSI on here, so it is FC only. You will need fiber channel switches to connect to the 5100 itself. Now, I say that as a matter of fact, but you don't have to have fiber channel switches. But your fan out ratio, as far as how many hosts you can actually attach to the array itself, drops dramatically when you don't have a fiber channel switch. It's just like an IP switch in your network environment. If you had to directly connect everything together, your choices would be limited. Same here. If you're doing fiber channel only, you could directly connect the host to the 5100 itself and get access to the backend storage. But if you want to connect many hosts well beyond the available ports, the 8 front-end ports that you have on the SPs themselves, then you're going to need a fiber channel switch. The drive types, now the disk and OE matrix, and I make reference of that here because I think it's very important. And EMC does a lot of matrix type documents. These are all PDF documents that you can go in there and you can view specific information as it relates to code on the array. In relation to the disk and OE matrix, it tells you, based on the code level that you have on your array, what disks are supported for my array. And that's kind of what I put here. For the VNX, all the way from the 5100 all the way up to the 7500, these are the types of disks that are available with their form factors on the end there. This won't change. That bottom drive type row will not change. But I wanted to make note to the disk and OE matrix, because and you can go out to support.emc.com right now, type it in, disk and OE matrix, and it'll come up with a doc for your particular array. That's how you know what drives are supported for that array itself. 5300, this is the unified entry into the vnx. So we looked at the 5100, that was block only. This is now gives you NAS capabilities. It gives you CIFS and NFS capabilities. And it gives you a couple other things too, but those are primarily what our customers are using them for, CIFS and NFS. Now the max number of drives, 125, 4 being the minimum. And this is what I like to call the Swiss Army knife solution or introduction to the vnx. Because it does do everything. It does do pretty much all data center protocols. So it's capable of doing fiber channel. It's capable of doing fiber channel over Ethernet. It's capable of doing iSCSI, NFS, CIFS, MPFS, and also the last thing was FTP, file transfer protocol. These are all the supported protocols that are available on the unified array itself. Now the max number of front-end ports, fiber channel ports, that are capable on the 5300 are 16. 16 front-end ports. Just like the 5100, it's 2 back-end buses. Now we're adding in the file-specific piece, because now this is a unified array. I'm now doing file and block from the array perspective. File-wise, I now have what's called a data movers that are introduced. And the data movers are just big, again, X-Blade servers that are processing data coming in on front-end ports on the data movers, and they're communicating with the back-end, which is the block side of the vnx itself. You can have anywhere between 1 or 2 X-Blades, data movers. On these data movers, they have I/O modules just like the SPs have themselves. Now each data mover has 6 gig of memory, and on the 5300, each data mover has 3 I/O slots per X-Blade. If I can go back to how many X-Blades are actually in the 5300, it says 1 or 2. Would you ever want to do 1 X-Blade? Well, that's kind of a tricky question. 99% of the time you would not. And here's the reason. If you lose that X-Blade and you're serving up an NFS export file system, or you're serving up CIFS data from the data mover itself, and it fails, you have nothing to fail over to. Therefore, you are down until you either replace that X-Blade if it needs replacing, or you get it back up. 9 times out of 10, you would always want at least, at a minimum, 2 X-Blades or data movers per array. This gives you an active standby configuration. That is how it operates by default. Now, you can get special privilege from EMC to do an active configuration with a 2-blade or 2 data mover configuration. Again, not common, not recommended. You have no failover if you were to lose one of those active data movers. But there may be a situation where you may want to use 1 or 2 data movers and have them both active, or not have a standby. It could be a test environment, it could be just a throwaway environment, it could be anything. But 9 times out of 10, as I mentioned before, in production environments, you're going to want at a minimum 2 X-Blades. Period. What's next? 5500. This is what I call the Unified Plus One. I'm trying to be hip and cool. Now this builds on the 5300 and adds, you guessed it, increased scalability. So now I'm taking the number of drives on the 5300 from 125 up to 250. I'm adding more cache. I'm cramming more cache into the storage processors themselves. I'm also increasing the back-end buses that are capable. There's a high bandwidth option that you can put on the 5500 that gives you increased buses, so increased bandwidth. So it gives you up to 6 back-end buses, the same number of front-end ports as the 5300. On the file side, you have options of scaling this from 1, 2, or 3 X-Blades. And you have different options there. Like you could have 2 active and 1 standby in a 3 data mover configuration. You could also have 1 active and 2 standbys. So certainly a couple different options you can do there. The data movers themselves in this configuration have 12 gig of memory, max of 36 for the array. So 12 times 3, that gives you 36, would be the max amount of memory for this the 5500 itself. 4 I/O slots per blade. You can do iSCSI, you can do straight up 1 gig copper connections. Supported protocols, all the usual suspects, and then the same drive types are supported on the 5500 and the 5700 and 7500, all the way down from the 5100 as well. 5700 is the unified plus 2. I'm hip. Builds on what the 5500 provides, adds increased scalability. Now I'm taking the number of drives from 250 and I'm doubling it to 500 is the max number of drives that I can do. Front end port, taking it up to from 24 to 36 gig for the SPs. The max number of fiber channel ports that I'm capable of doing on the 5700 is now 24. Huge amount of fiber channel ports for the 5700. 4 back-end buses, so it was the minimum of 2 on the 5500, and they had a high bandwidth option where you could do 6. The 5700 takes it to right dead in the middle with 4 back-end buses. As far as the file side, now I'm able to do 2, 3, or 4 X blades. Each blade has got 12 gig of RAM, and then the max number of memory is 48 for the array itself. 4 I/O slots per blade. Supported protocols and drive types are the same. So the vnx 7500, here comes trouble, as I like to call it. So this is where things really start to blur between, not too much, but it really would start to blur between the Symmetrics line, the 7500, and the mid-range line. Now, some people will say the mid-range line is not enterprise. I very much disagree. At least from the 5300. Well, 53, 5500 up to the 7500 is really where you can get these levels of performance that you need in an enterprise environment. Now, it's not an active head design like the Symmetrics itself. So if you do lose an SP, you do lose one of these heads, you could potentially have performance degradation problems. Very unlikely on the VNX. It is leaps and bounds over its predecessors. But it is possible, and especially in comparison to the Symmetrics itself, where you could lose multiple directors, you could lose multiple engines, and still, not it be but a blip on the radar. It still very much could provide the capability that you were used to prior to the outage, whatever the piece of hardware that you lost. Now, with the 7500, you're taking the max number of drives up to 1,000. Okay, you're doubling it again from the 5700 up to the 7500. Huge amount of drives. Now the Symmetrics itself, if we're looking at the higher end active arrays, these are capable of providing 2,000 plus drives. So just to give you a comparison there. Cache, 48 or 96 gig of front end cache on the SPs themselves. And then the number of ports, you're doing 32 front end fiber channel ports per 7500. It's huge. It's a huge amount of front end ports. I mean, you've now got options. And on the back end, you're stacked as well. You're doing 4 or 8 back end SAS buses. I mean, that is huge as well. And you'll want that at the 7500 level. One, because now you've got more drives. You're stacking more stuff on it, stacking more applications. But also, you probably got a mix of nearline SAS, and flash drives. Flash drives have the tendency to flood a bus or buses, particularly in the predecessor technology, particularly in the Clarion line. So the more back-end buses you have in comparison to the more flash you have is certainly beneficial. From a file-specific level, you now have 2 to 8 X blades. Each X blade has 24 gig of memory. The max for the array is 192 gig. And then on each of those data movers, you have 4 I/O slots. Now these slots can be filled with modules that have 1 gig copper, 1 gig copper and fiber, FCOE cards, could be fiber channel cards as well for back-end connectivity to the VNX block itself. So lots of different options there. Supported protocols, same across the board, all the usual suspects there, and then drive types as well.